So now I'm inviting up Elizabeth Boswell from University of Glasgow, and she has been analysing the query logs from the 2025 DNS-OARC Day in the Life data collection with a focus on AS112, harmless junk queries, but just how harmless are these queries actually? Elizabeth.
Hello everyone, so I'm going to talk about the security and privacy risks of junk DNS queries. So what do I mean by junk queries? So these are queries sent to the DNS that don't have a meaningful response. So a very good example are reverse DNS queries for private IP addresses. So if these queries are sent to the public DNS can't possibly give a meaningful response to this query. Since these are private addresses, they can't correspond to a single domain name in the public DNS. So these queries are essentially meaningless junk that is sent to the DNS and just wastes resources. So in order to deal with this problem, the AS112 network was created, which is an anycast DNS deployment that captures these junk queries and diverts them away from the .arpa and .inatu.arpa name servers, which would otherwise have to respond to these. So AS112 servers are the name servers for reverse mappings of RFC 1918 private addresses and linked local IPv4 addresses, and the special use domain names home.arpa and service.arpa. And just to be clear, when I'm talking about reverse mappings, I mean this is the way you manipulate an IP address in order to send a reverse DNS query. So you take the constituent parts of the IP address, reverse them, and append inatu.arpa or ip6.arpa, depending on IPv4, IPv6. And then you send a pointer type query for this domain name, for the reverse mapping. Well, the special thing about AS112 is that this is a volunteer-run network, meaning that anyone can add a site to this network. It's only loosely coordinated by DNS-OARC, but pretty much anyone can contribute by just setting up a DNS server and announcing the relevant anycast prefixes. And then they will start receiving a share of the world's junk query traffic. In some previous research, we looked at the deployment characteristics of AS112, and we found 469 sites run by 97 operators. Cloudflare is a major operator. It runs about half the sites we found. But as you can see in this chart, there's many other operators as well. But this is not the focus of this research, but I will talk more about this in the RIPE DNS working group if anyone's going there. The focus of this research is the queries that go to AS112. So as I said, AS112 is volunteer-run and uncoordinated, but the choice to run AS112 in this way relies on this implicit assumption that any traffic that goes to AS112 is harmless, so that anyone can answer these queries and it's not a big problem. So we're trying to see, is this assumption actually justified? So our questions are, what queries are sent to AS112? What could a malicious operator do with these queries? And I should say that this is a work in progress and these are preliminary results, and I'm definitely looking for feedback if anyone has any ideas about what is going on here. So our data set, as Kathy said, is the DNS-OARC Day in the Life data from last year, covering 48 hours last April. We have data from 3 different AS112 sites. It's the RIPE site in Amsterdam, the WIDE site in Osaka, and the TIX site in Dar es Salaam, which in total covers almost 2.8 billion queries sent by almost 400,000 clients. And in analyzing this data, we found reverse DNS queries and DNS dynamic updates, but also service discovery queries and what I call lame delegated queries. So first of all, the most expected type of traffic are reverse DNS queries for RFC 1918 private addresses. And we did find a lot of these. It's about 38% of the queries are just regular reverse DNS queries. So regular junk queries which should be going to AS112. Another large percentage of queries are other queries for RFC 1918 reverse mappings. So about a third of these, 27%, are just other query types for reverse mapping. So reverse DNS queries are always pointer queries. These are SOA queries or NS queries. About half of these 27% are of the form _ reverse mapping. So service queries always start with an underscore. So I think these are somehow malformed service queries which are sent to AS112. There's also a large number of queries that appear to be for personal devices. Almost 10% of these 27% contain the word iPhone, so it's like iPhone.reverse mapping. So some of these are being sent to AS112. Another large contingent are DNS dynamic updates. So just a quick reminder, they're used to change the contents of a zone. So for example, DHCP can use these when a client joins a network. It uses dynamic updates to add the host name to the local DNS, and it can also remove the host name again. However, dynamic updates are sent to AS112 if a host uses a private IP address, updates its reverse mapping, so IP address to host name, and the local DNS doesn't serve the reverse mapping zone. So the local DNS doesn't know what to do with this, and it ends up at AS112. This kind of traffic is known to go to AS112, and it has been studied in the past, about 20 years ago, but we can confirm that this is still happening. So about 6% of the queries that we saw are these reverse mapping, are these dynamic updates. And even though this is expected, it's not without harm, because these dynamic updates contain the host name that's being updated. So a malicious operator could use these to learn about the local network configuration, and they could also track individual users. If they know that someone owns a particular device, they could then use this to check when are they entering a network and when are they leaving the network. So a more unexpected type of traffic that we saw are service discovery queries and service queries. And this is due to interaction between AS112 and what's called DNS-based service discovery. So DNS-based service discovery allows clients to discover services on the local network using unicast DNS by sending queries of the form _servicename._protocol.local domain. So for example, if the local domain is example.com and the service is IPP, it would be _IPP.udp.example.com. The problem is that when joining a network, the client doesn't know this local domain beforehand. It has to discover it. And it does this through queries of the form lb.dnssd.udp. What I call the bootstrap domain, which is sort of a best guess at what the local domain would be. And according to the RFC, this bootstrap domain can be the reverse mapping of the local address. So if the local address is the RFC 1918 address, and the local DNS doesn't actually serve this zone, these queries will also go to AS112. And this, in fact, happens very often. It's about 18% of our queries. And this is a problem because the malicious operator could then misuse these queries to spoof the service. So as seen in this graph, the client would send this discovery query, the malicious operator would return some malicious domain, and then any subsequent service discovery queries would go to this malicious domain and to infrastructure controlled by the attacker. Of course, this kind of attack would fail if the service is authenticated, and that's why I'm saying this is preliminary work, because I need to do more research to find out how much this is a problem in practice. However, there was some previous work on service query leakage in other contexts, I think in 2017, which did find that a lot of services don't properly authenticate. So I do think this might be a concern. Similarly, almost 7% of the queries are service queries, so they contain a service name, so they are likely a part of like a further step down this process where it's actually looking for actual services, or they are associated with what's called DNS push notifications, which is a way of getting continuous updates on services. These queries cover 320 different services, of which Matter was the most common. This is an IoT protocol. And similarly, these could potentially be used to spoof the service if it's not properly authenticated. And finally, there's one category of queries which I can't really explain. It's 0.35% of queries are for domains that are not delegated to AS112 and that have a public top-level domain. So these are regular domain names whose queries are somehow ending up at AS112. And the risk here is obvious. A malicious operator could then respond and spoof the site. These cover about 38,000 domains. However, 43% of these queries are for one domain called strepsils.top, which is a malware or phishing domain, so don't go to this domain. But, but in trying to find out what's happening here, I looked at historical zone files from DNS Coffee and historical WHOIS data from VirusTotal, which I was able to get for about 20,000 of these. And I found that 95% of them were delegated to AS112 in the zone file. So either the owner of the domain or maybe the registrar set up the zone file to have this lame delegation to AS112. And 75% of these use the same registrar called hosting concepts BV. And a quarter contains sort of gambling-related words in the domain, like something bestbettingsites.com or something like that. So I think maybe this is some kind of content filtering thing, or maybe a malicious attacker doing something. I don't really know, and I'd be interested if anyone has heard anything about this and has any hints on this. But in conclusion, we looked at 2.8 billion queries from 3 AS112 sites and found dynamic updates, service queries, and lame delegated queries. So AS112 does not only receive harmless reverse DNS queries, which kind of calls into question the whole model of running AS112 as this volunteer-run network, and it might be worth rethinking that organizational structure. So, thank you, and does anyone have any questions?
Thank you very much. And we have our first question.
Hey, Warren Kamari, Google. Could you go back a slide? So for the last part, yeah, the people delegating it, sort of name servers to AS112, ICANN SAC actually has a document mentioning that, SAC 125, SAC report on registrar name server management. And yeah, it was some set of registrars who didn't want to deal when a name got removed. They would just like update the name server records to point at AS112 or a name in AS112. For some reason, they thought that was a good idea.
That's interesting. Thank you.
And better?
Petr Špaček, I see the underscore, period, and the rest of the name is most likely an old version of bind doing query name minimization, which very nicely ties to the previous talk.
Yeah.
That version is end of life for God knows how long, but people don't like to upgrade.
Are you talking about the one where it's just underscore dot and then reverse mapping?
Yes.
Oh, okay, that's good to know. Thank you.
And I actually do have a question. What actually led you to think about the AS112 query handling and ask whether or not there was a potential for threat and for their misuse in the first place?
So the previous research I did was looking at the operators and kind of looking at who's running this, and this is sort of a natural follow-up of that, like anyone can run this, and what could they actually do with these queries? And I guess more generally, it just seems interesting because it's sort of a strange edge case of the DNS, which just seemed like kind of interesting to look into in general.
Mm-hmm. Thank you. Oh, there's one remote question. Or possibly two.
Just came in from Petr Mesnik. Sorry for mispronouncing the name. Can Linux platform vendors do something to prevent DNS-SD for updated system, for example, for domain received from the DHCP?
Sorry, I didn't quite understand.
So the question is, can Linux platform vendors do something to prevent DNS-SD for updated system, for example, domain received from the DHCP? I don't know. I was discussing with
I think we might have to do that on the channel.
Yes.
So thank you to Elizabeth.
Thank you.